3, 2, 1, go. We're live. This is Retraice segment number 75 for Friday, December 9th, 2022, 11 p.m. Eastern, 8 p.m. Pacific. Retraice is about what's going on out there. Short answer to that is computer control. Long answer to that is not going to happen right now. Mathematical disclaimer. I should not be your mathematician. Artificial intelligence disclaimer. I should not be your AI engineer yet. Maybe ever.
Go. We're live.
Maybe something was going to go wrong. Okay. We got to get ready. Look, this is taking too long. If you don't know what we're doing, look at the title of the video. Gradients and partial derivatives, part 6, artificial AIMA4e page. Threw me off my game. This is going to be a terrible experience for you. For me, I'll be fine, but you'll be struggling. We're gonna place an airport. That's all we're gonna do today. It won't be that terrible. Look at the guy in the photo that I put with the show. He's waiting. Everybody's waiting. I'm going to show you what it's like. You think just placing an airport is a thing that you can just go do? I'm going to show you what it's like. Let's do this. Okay. If you're looking to get up to speed, go back through all the Retraice notes, starting with Retraice 70. We'll show you everything. Now we're on Retraice 75, and we place this darn airport. There you go. Done. Okay. Here's Fagarash, Bucharesti. First airport. Is that a good guess? Did I do good? I know I didn't do good. Look, we didn't want to put it right here. We don't want to put it right on the line. First of all, we couldn't easily do that just eyeballing it because the arithmetic is not easy to eyeball. I guess, no, because look, this line does not go through any, anyway. I gotta budget my time here. Like this, I'm spending a lot of time on this. All right. I placed it here because I want to be able to do gradient descent on the thing. I know it's not going to be as good as over here somewhere, and I want gradient descent to push it over here. I don't want to, okay, fine. So we picked the nice clean coordinates, 18, 11, x equals 18, y equals 11. That's our airport guess. We've guessed the location for an airport. Let's see how happy Fagarash and Bucharesti are. What this means, our guess amounts to these numbers down here and one set, 3 numbers in one set. So our first number is one of the cities, second one's another city, third one's the location of the airport, and then finally we're going to need to specify what this set of cities C sub x sub 1, C sub x sub 1, you didn't think you'd hear that on a podcast today, means below in when we plug it into our formula. Okay, so we've got our 3 simple, this is the simplest version of the airport problem. We've got 3 coordinates. Let's go see how it all turns out, okay? See how much it turns out? Okay, so we start at the top line here. Before we talk about the gist of what we do, this is our formula from previous days. It's just the formula for calculating f of x, which is our objective function. F of x expands into multiple variables. In the case of the 3 airport problem, we have 3 sets of xy coordinates. In our problem, x sub 1, which is our particular little first dabble, we've only got 2 variables, x and y. So in the first line, we just have the algebra. In the second line, we start plugging in numbers. Here first, we plug in our first airport, okay? Our airport is at 1811. Look at it. See? Told you, okay? We plug in the airport here. We don't plug it in over here for reasons I'll explain in a second. The second line here, we don't need this sum. We only have one airport. So I from 1 to 3 is the problem in AIMA4e. But if we're only doing one airport just to get our feet wet, we're going from I equals 1 to I equals 1. So we don't need this. So we get rid of it. Okay. Get rid of the second sum. Don't do anything else. Next line, plug in set algebra. What do I mean by that? Up here, this says for each city that is in the set of cities closest to the airport I, okay, can you see that? For each city that's in the set of airports, a set of cities closest to the airport I. Well, we've already picked our airport. There's no need for it to be I. It's airport x sub 1 because we only have one. Our vector only has one airport in it. So now we're talking about the cities that are in the set of cities closest to airport 1, and we plug in the coordinates of airport 1. X sub 1 and y sub 1 over here. And why is that? Did I make that red? That shouldn't be red. That should be blue. I can't believe it. How did I miss that? Okay, anyway. So plug in the airport coordinates. I got it right over here, but that should be blue. Okay, 18, 11. Those are our airport coordinates. Now they're over here. We have to expand this summation notation. What does it look like when we expand it? Well, we only have 2 cities. Okay, so over here we're saying for each city in the set of cities, do some arithmetic. Well, we only have 2 cities, Fagarash and Bucharesti. So here's Fagarash and here's Bucharesti. Okay, so what I'm saying here is you take the coordinates of the airport, 18 and 11, and you have to do some subtraction with the corresponding coordinates from each city. So this is the x coordinate of city Fagarash. This is the y coordinate of city Fagarash. This is the x coordinate of city Bucharesti and the y coordinate of Bucharesti. Okay, and then we just add those two together. Remember, we're adding up this term for a certain number of i's, or in this case, it's for a certain number of elements in our set C, big C, and that's how we're going to get our f of a function of the airport location. Okay, that's how we're going to get our objective function value of the airport location. And then from here, once we take the coordinates of the 2 cities, the 4 coordinates of the 2 cities, 14, 13, and 19, 6, we plug it in. It's just arithmetic. Okay. I'm pretty confident in the arithmetic here, but I spent a lot of time just formatting this and getting the colors consistent, and I still missed one. I can't believe it. And look at how obvious it is too, and I still missed it. But I also checked it with a programming calculator, so I'm pretty confident in this function score. But okay, listen, I put these little notes here at the end. I'm starting to get into margin notes because I don't know, they're useful sometimes. Toil, mundane, can't pronounce words. Mundane, repetitive, operational work providing no enduring value, which scales linearly with service growth. And that's from Site Reliability Engineering, Bayer et al. And then I was looking in a quotes book for something about explanation. A little inaccuracy sometimes saves tons of explanation. That's from Munro, H.H. Munro, who was under a Saki or some pseudonym, a Scottish novelist, I think. A little inaccuracy saves some explanation. All right, well, here's a lot of accuracy and a lot of toil. And what does this correspond to? I mean, we just calculated the objective. Did we do any gradient descent? No, we didn't. All we did was, given our objective function of squaring the straight line distances here and here, which probably should be in this diagram, I guess. Should definitely be in this diagram. But anyway, they're not. And I'm not going to do it because it's not necessary, because a little explanation, a little inaccuracy saves explanation. All we're doing is trying to figure out the score of this airport to find out how much the people will like it. Okay, it's a little bit closer to Fagarash than to Bucharesti. We can kind of see that just eyeballing it. And we know, based on our objective function, based on the way we designed it, that when gradient descent comes and helps us and moves it over here, the score is going to go down. We want this, 46, to go down as far as possible. And we won't know for sure that it's gone down as far as possible until we consult gradient descent, although we only really need to just average the distance here because we only have 2 airports. But that's not the point. We're not doing this to do the easy way. We're just looking at how much toil and explanation we would need just in the simplest case. And that's all we did here today, okay? So yeah, we got to calibrate here. Like, I'm spending a lot of time just making sure that I'm not just doing the math, but also like formatting it for the notes. And it's not really necessary, but it's for a first pass. I want you to understand that. But then here I am, like I've fallen back into that thing that I didn't want to do, which is sort of teaching. Like I shouldn't be your math teacher. I shouldn't be your AI teacher. I'm learning it myself. So I think I'm going to distinguish between explanation on the one hand and teaching on the other. I want to be able to explain things, but the level of detail that I have to go into to try and really make sure that almost no one is going to struggle with this, it's taking too long. I'm going to spend a lot of time formatting and not a lot of time learning AI. So that's where we'll be going next. That's it for today. How we're going to code next step is to do the gradient descent. And I don't know how long it's going to take because I've never done it before. And then we have to code at least some of this. It was so ridiculous, doing this math in a markup language, and it's just wrong. We got to find better ways of doing this. So that's where we're going next. Okay, amendments and corrections. Yesterday, I said during the live stream during Re75 that the distance between the 2 cities would be half of 74, and because we were calculating what were we calculating? I mean, we were calculating the distance between the two cities, which we shouldn't even have been doing, but it was, it was fun. It wouldn't be half of 74, it'd be the square root of 74. And I said that half of 74 was 37.5, and it's not, it's 37. I should not be your math teacher. All right. All references will be in the PDF notes, retraice.com, retraice.com. Same time again tomorrow, 11 p.m., 8 p.m. Pacific. Signing off.